Okay, part two. I got cut off there. Um, the thickness of the basement wall is based on what type of material you're going to have, how tall of a structure, and the amount of what the book calls unbalanced fill. Okay, meaning how much dirt, how high the dirt is outside as opposed to how high something is on the inside. Okay, so if we're doing concrete masonry block, that's going to be hollow load bearing, and we'll say we're doing a frame house. Okay, which is normal. Okay, if we use 8-inch block for our foundation wall, we could have a 5 foot difference, meaning the dirt could only come up 5 feet higher than the basement floor. Okay, if it goes, if we go with a 12-inch block, we could go up to a 7-inch, uh, or excuse me, 7 feet of unbalanced fill. A solid load bearing is could be block, could be solid concrete wall, in which now you can pretty much go 7 feet, you know, for both of those. And there's some other variations. This is just a general guideline. There's other variations based on the building codes. Okay, we can add what's called a pilaster into a masonry wall or a poured wall. And what this does is it provides a like a column built into the wall that provides reinforcing to the wall itself. Often, if you have a beam, then the beam will rest on the pilaster. Okay, and they're used to kind of stiffen and support the wall. Now, there are other things you can do in a masonry wall with horizontal reinforcement or even vertical reinforcement within the cells to strengthen the wall. And of course, a poured wall is going to have rebar, reinforcing bars, uh, kind of in a grid inside the concrete. So here we have a section of a basement wall. Okay, we've got our footing, our slab. This is with concrete masonry units. We've got a sill plate, and then our floor joist up here. The top of the wall, right up here, should be at least 8 inches above the ground, the dirt on the outside. That's to prevent termite infestation. Wood sills, which is very common, you'll have a pressure treated sill that goes on top. That is anchored to the wall mechanically. Um, Often if you're doing a masonry wall, you have a solid cap at the top that closes in all of the holes and it prevents things from going up and down into the holes. And then on the outside, you're going to have some damp proofing. It's not waterproofing, it's damp proofing. And then some method, and that prevents ground moisture from penetrating into the wall. And then some method to move groundwater away from the wall. And that's what a drain tile would be for here. And so here's an example of one type of anchor clip in which the sill is anchored to the block or to the concrete. Okay. Traditionally, they used anchor bolts, which are shaped kind of like a J or an L, but these are much quicker to install. Okay, here's a method for the water removal, in that you'll have a drain tile at the bottom of the foundation, and it gets covered with gravel and then backfilled with dirt on top of that. And any water will accumulate in that gravel and into the drain tile, and that goes all the way around the basement, and then it drains off on the low side. There are some products that are the actual formwork for the footing that have little holes in it, as you can kind of see in the graphic here. And then any moisture that builds up into the ground can go into those weep holes, and these forms are hollow, so they're like rectangular shaped pipes, and they drain off to the outside of the building also. Okay, loads. Building codes uh, specify what type of dead loads and live loads are used in a building design. Dead loads is the weight of the structure, things that are permanently attached to the building, and based on what your building is made of, there's a set rule that you go by of so many pounds per square feet. okay, based on what type of construction you've got. The live load are things that are moving or can move, okay, furniture, appliances, people, snows, things like that, okay. And building codes have lots of charts on how to determine what these are. It's just kind of an introduction to you on it because in sizing a beam and a column for a footing, you have to know how heavy the building is. And so the exterior foundation walls carry the entire load of the exterior of the building and half of the span to the interior bearing wall. Okay, the interior bearing wall only carries this area in green because that's what's pushing down straight on it, and then basically half of what you've got going over to the next bearing point. Okay, so this beam could be wood, could be steel. Okay, and it supports all of your floor joists that are going down through there. So basically, what you would do is you would figure out how much your roof weighs, how much your ceiling, your floors, any interior walls, how much they weigh of what is in this particular area. And then we say, okay, that's X number of pounds for this area here. And we say, okay, we're going to use 3 columns, so that gives me 4 spaces there. And so you kind of divide it out mathematically, and you figure out what kind of weight one column will carry. Okay, and then that column and the footing under it is sized based on the amount of load that that would carry. Okay, sounds more complicated than it really is to figure out. Okay, so yeah, this is another graphic of a basement floor against a wall and some of the details of what would go into the building that. Concrete floors, uh, most are 4 inches thick, could be 5, 6 inches thick, depends on where you are, what you're doing. It should be a lot of the books will say place it on sand. Uh, Mostly what I see is compacted gravel with a layer of plastic laid down over it to prevent moisture from coming up into the concrete. And the sand or the gravel is to provide a place for any groundwater that would come up to rest in that gravel and sand before pushing into the concrete. Okay. Anytime you have a penetration through the floor should not bond to it. Like here at the edge, we'd have a joint, bituminous joint. Okay, it's a joint filler, and that's an expansion joint so that the floor can kind of give and expand and contract a little bit. Okay, concrete blocks. Um, you got lots of various shapes and types and things like that. The basic block is going to be this right here, your 3-core, it could be a 2-core stretcher. That's what you see most of the time. And it's called an 8 by 8 by 16. Well, it's actually 7 5/8 by 7 5/8 by 15 5/8 because you have a 3/8 inch mortar gap between them. Okay. So this is your most common, and then you may have a corner block or a double corner, and they got all these other kinds of things that come in there also. Okay, so that's just a real quick overview on footings and foundations and concrete.